are going to study the fundamental theorem of arithmetic. Before going to the topic, I just revise some basic concepts which are related to this only. Okay. Now, you know the factorization, you know the what is mean by the prime factorization. That only I am going to revise first. Now, suppose that you are taking the number 300. Okay. Just we are revising the basic thing which are required to understand this fundamental theorem. Okay. Now, if I take the 300. Okay. Now, how to factorize 300? There are many ways to factorize. Somebody can return 30 into 10. Again 300. Okay. Somebody can return 150 into 2. Again it is the 300. Okay. Now these are the different way you can factorize this. Okay. But it is not the prime factorization. Now if I want to do the prime factorization, suppose student 1 started from this and another student started from this. Now I am going to factorize this again as it is the prime number, so it is as it is. Now it can be factorized 15 into 10. Okay. Now both the numbers can be factorized in the terms of their prime factors. That is, this will be 3 into 5 and 10 can be written as 2 into 5 and this 2 as it is. Okay. Now what is the prime? You have started the factorization. Okay. First, then again you got some number which can be factorized according to their in terms of the prime factors. Okay. Now this, if I can write, what is mean? This is nothing but the factor tree. You have already familiar with this. Okay. So 300 can be written as, now this completes, every factor is a prime number. So I am rearranging them. So it is 3 into 5 into 2 into 5 into 2. These 300 is represented as a prime factorization. Okay. Now this is one way I have done the prime factorization. Started with the 150 into 200. Now I am going to towards this. Now I can factorize this 30, 3 into 10 if I want to, and I can factorize this 2 into 5. Okay. Now again this number can be factorized in terms of the prime factors. 3 into 2 into 5. Okay. Just these are already prime factors, so take it out as it is. 2 into 5. Now if this is the all the factors of 300 are prime. So again I can rearrange 300 is equal to 3 into 2 into 5 into 2 into 5. Now if you can observe, if I can write these numbers in the by using the power forms. So 3 how many times? 1 time. 2 how many times? 2 times. So I can write 3, or I will arrange in the ascending. 2 square, then as 3 and then 5 square in terms of their power of the product. So okay, power of the factor. This also can be written. Okay. Here 3, 5, 2, 5, 2. Here 3, 2, 5, 2, 5. Though the factors are arranged, but the factors are the same. Though they are arranged in the different orders. If you observe these two things, orders are different. Here 5 is at the second place, here 2 is there. But ultimately you can write this also as 2 square into 3 into 5 square. If you observe this, not depending upon their order, means the prime factorization of given number from whatever you start the factorization is always unique. And this is nothing but your fundamental theorem of arithmetic. Now come to the statement. What is that? Every composite number means, composite numbers means having more than 2 factors, obviously. Okay, keep in mind that 4 is the smallest composite number, as 4 has the factors 1, 2, 4, more than 2. Okay, the every composite number can be expressed or factorized as product of primes that we have seen. This any number, that is 300 I have chosen. chosen, and then it is can be factorized in the product of prime numbers. These all are the prime numbers. Okay, and this factorization is unique. That only we have proved. I have started from 150 into 2. Here I have started 30 into 10. But ultimately, when I come to the prime factorization of 300, I got 2 times 2, 3 one time, and 5 2 times. So uniquely, though I have started from the different factorization. So, and again, apart from the order in which the prime factors occur, apart from the orders means orders can be different, but that prime factors are same and their powers. Okay, here 2 times, here also 2 times, here 3 one time, here also 3 times, here 5 2 times, here also 5. Means apart from their order, this prime factorization is unique. The statement you have to learn because it is generally asked. State the fundamental theorem of arithmetic. It is nothing but only that simple way you can state that the composite numbers are composite numbers are expressed as a prime factorization, and that prime factorization is unique. Apart from their order means order can be, you can write like 3 into 2 square into 5 square like this. Nothing else. Okay. So try to read out this and try to remember this statement that every composite number can be expressed as a product of prime factors, and this factorization is unique. This complete statement you have to write. And apart from the order in which prime factors occurs. Okay, this is the statement. Now it can be also stated like this also, that the prime factorization of a natural number is unique. यूनिक होता है वो, and except of the order of its factor, means their factors can be arranged in different way, but the factors are same. If you observe this example, you can get that how this statement we have already familiar of this. Okay, so now what is the use of this fundamental theorem of arithmetic? Arithmetic is used to find the SCF, LCM, relation of the numbers and their SCF, LCM. That we will now let us see how to do the prime factorization. While doing the prime factorization of given number, just choose the prime. Remember all the divisibility tests, so it will be easy for you. Now for this, now you know that as this number can be divisible by 5. So let us divide it by 5. You will get 5 into I think 7,065. Okay, sorry, 765. If you divide this number, as here is a 5. Okay, this thing all you know. Okay, now again I am dividing with the 5. Okay, so 5 ones are 5, then 2 remains, 5 5s are okay, then again 5 3s, I think 153. Okay, then now as this, now you have to divide this one. Okay, now this 5, it will not get divided by 5. Now try to divide with the another prime number. It may be divided by 3, as 3 plus 5, 8 plus 9. So I will divide 5 into 3. So it will be 51. Now is it 51 is a prime factor or prime number? So no, it is again can be factorized. 3 into 3 into 3 ones are 3, 3 sevens are, means 17. Now you know that 17 is a prime number. So here we completed the prime factorization of this given number. Just one rule is there. Always arrange this prime factorization ascending orders of given factors, means you just have to write this 3 first. It is conventional. If you want to write like this only, it is also okay. Now I will write 3 how many times? 2 times. 5 how many times? 2 times into 17. Okay, as 3 is smaller, so arrange that prime factors in this way of ascending order of their prime factors and write in the power form as you are in a 10th standard. In this form it is expected. Now let us see another example. Now again 5 is there, so 5 into divide, you will get 1001. Now this number, apply the divisibility test and you come to know that this number is divisible by 11. Okay, so again 11 is a prime number. Okay, you have to choose the prime number into 91. Okay, 11, is it correct? Okay, now 5 into 11 into 91. Is it 91 is a prime number? No, it can be divisible by 7. Then you will get the 30. Now here you complete the prime factorization. Just we are rearranging it in the order of ascending order of the power factors. Okay, 5, 7 into 11 into 13. Okay, this is the prime factorization of this. Okay, now next number is I think 7,429. Now this type of do the practice of some prime factorization, because every time it is not possible that you are getting the prime factors easy like 5. So here which number can divide this, you have to search. Now here 17, you will get 437. Now 17, this number is divisible by 19. So 19 into 23. If you multiply this, you will get this number. This is how you can do the prime factorization. For that, you just have to remember all the tables and divisibility test. We will see the application of fundamental theorem of arithmetic for finding HCF LCM in next